In this skill video, we are going to learn to rationalize monomial denominators. Monomial means there's only one term in the denominator. There is a different method for rationalizing with binomials in the denominator, but we will only focus on monomials. So first, you have to be really careful because the question may not actually say rationalize the denominator. It might just say simplify or express in simplest form with a rational denominator. Little background information for you. The square root of 6 is a non-repeating, non-terminating decimal. It goes on and on forever and ever. In math, it is conventional to not leave your answers with radicals in the denominator. We'd rather them be in the numerator. So the process for that is very simple. You take whatever your denominator, whatever your fraction is, you find that denominator, look at it, and then you write a fraction right next to it. And look at what my fraction is. It's the denominator over itself. And I drew a little dot here because we are going to multiply. So the step is to multiply by the denominator over itself. Why am I allowed to do that? Well, anything over itself is the number 1. If you don't believe me, type this into Desmos and you will see that it's equivalent to the number 1. So when you multiply by something that is a form of 1, but isn't exactly like the number 1, but its value is 1, you're usually changing the way it looks. So in math, we often manipulate by multiplying by a form of 1. The same way that if you had the fraction 1/2 and you wanted to change it into a fraction over 8, you would multiply by 4 over 4, and you would get 4/8. These are equivalent, and the thing we multiplied by, 4 over 4, is 1. So you've been multiplying by 1 your whole life. You just haven't seen it in this context. All right, so now what? Okay, a whole number times a radical will wind up looking like this. The whole number stays on the outside, the radical stays to the right of it. A radical times a radical. Now we've learned already that a radical times a radical is done by multiplying the radicands together. So 6 times 6 is 36, and then whatever you get down here will always be a perfect square. Why? I mean, just think about breaking it down. It breaks down into the two numbers you just multiplied together. So we break it down. 7 radical 6, the denominator is 6. Double check to see if this simplifies, because sometimes that turns into like 8 over 6 and it simplifies, but 7 over 6 doesn't. So this is actually our final answer. All right. Let's try another example. Example 2. In example 2, we have to express in simplest form with a rational denominator. So if you're looking at any problem and you happen to notice that there is a radical in the denominator, you want to think, oh, I got to fix that, because in math, they don't like that. We don't like radicals in the denominator. We do not like irrational numbers in the denominator, so we like to rationalize them. To do that, we follow the step, multiply by the denominator over itself. The denominator is the square root of 3. Follow across. 4 times the square root of 3 is 4 square roots of 3. A whole number times a radical just stays as the whole number outside and the radical inside. However, in the denominator, we have a radical times a radical. You can multiply those together. So 3 times 3 is 9. The square root of 9 is 3. Check to see if the coefficients, or the numbers here, simplify, and simplify them if you can. In this case, they can't, so we're done. Do not simplify this 3 with this 3, because that's actually the square root of 3, which is, I think, 1.73. So those two numbers aren't even the same. So this is our final answer here. Let me see if I can find one.